right, we are back. We are still on lesson 1-5, but this time we are going to, actually, we're not going to do the nearest tenth like it says. We're going to kind of do a little bit different, but we're going to place these things on a number line. Now, it kind of builds with what you did yesterday, and it kind of just takes it to the next step. So, yesterday it said the square root of 10, and of course you went to your chart, so make sure you have your multiplication chart handy. The square root of 10 is going to fall between 9 and 16, so of course you've got 3 and 4 as your closest integers. So square root of 9 and the square root of 16. The square root of 9 is 4. The square root of 16, whoopsie. Erase that. 3. And the square root of 16 is 4. But now we're going to place it on a number line. So what we're going to do is kind of just draw ourselves a number line right under here like this. This would be 3. This would be 4. And then we have to place the square root of 10. Well, where would the square root of 10 go? Probably right about here, about the square root of 10. So the square root of 10, if we placed it on a number line, and I'm going to put it in, let's put it in red so it sticks out. It would go somewhere right in here, right after 3, because 9 and then it's 10. So I'd put a dot on the number line and then write the square root of 10 above it. And there, I'm done. All right, so let's just do a couple more. The square root of 47. So again, go to your numbers chart. Square root of, what was I looking for again? I forgot already. 47. So the square root of 47 is between 36 and 49. So the square root of 36 and the square root of 49. The square root of 36 is 6. The square root of 49 is 7. So again, I'm going to draw myself a number line. This would be 6. This would be 7, so I'm just bringing those down. And then 47, where would it fall? Well, this is 36, this is 49. 47 would be down here, wouldn't it? So when I go to put my dot on the number line, it'd be closer to 7. That's the nearest integer, the closest integer. So I put a dot here, and I list the square root of 47. All right, we're gonna do one more, and then I'm gonna change something up here. Okay, so now the square root of 62. Let's do number 5. So the square root of 62. So I go back down to my chart. 62. 62 is going to be between 49 and 64. So the square root of 49 and the square root of 64. The square root of 49 is 7. The square root of 64 is 8. So now I'm going to make myself a number line. We've got 7 and we've got 8. And then 62, 49, 50, 50, all the way over. 62 is going to be somewhere over here. So again, I'm going to put it on my number line right below here. And then I list the square root of 62. So placing it on a number line. So then I said I'm going to change it up a little bit. So we have to change this one up a little bit. I'm going to make this a negative 11. A negative 11. So I'm changing it up a little bit. So remember, the negative sign really doesn't do much. You still use the same process. So let's go to our chart. 11 would be between 9 and 16. But instead, 9 and 16. Instead, I just put a negative in front of it. So this would be a negative 3, and this would be a negative 4. But when we do a number line, if you're thinking of a typical number line, I'm going to draw one right here. Typical number line, it's 0, right? And it's got 1, 2, 3, which is good to go. But how's a typical number line over here? It'd be negative 1, negative 2, negative 3, and then negative 4. So when I go to do this, I kind of have to flip-flop these two numbers because technically negative 4 is more to the left and negative 3 is to the right. Okay, so negative 11, is that closer to 9 or is it closer to 16? Well, it's closer to 9. So that means my number, it's got to be between 3 and 4, but it's going to be closer to 3. So when I go to place my dot, it's closer here. So just be careful. If it's a negative, you have to flip the number line. So flip the number line, okay? All right, one other thing we're going to do today, so that's number lines. The other thing we're going to do today is talk about whether it's rational or irrational, and we need to decide what it is. So let's kind of go back to knowing what a rational number is, and I'm going to write it right here, rational. A rational number is a whole number, a fraction, or a decimal. And remember, there were two special decimal cases, one that either terminates, which is just fancy for ends, or repeats in a pattern. Irrational numbers is what we've been talking about lately, and their technical definition would be it cannot, I'm going to underline not, be written as a fraction. And I affectionately refer to these as pukers. I guess it wouldn't be a dot, it'd just be kind of in parentheses, pukers. It repeats randomly. Okay, so we have some of these numbers, and I have to decide, is it rational or is it irrational? So I have the square root of 3. Well, with deciding whether it's rational or irrational, I have to think about the square root of 3. The square root of 3, is it a perfect square? Nope, it's between 1 and 4. So if it is not a perfect square, it's irrational. So I'm going to put over here, not a perfect square. Because a lot of students think, oh, if it's just a square root, it's automatically irrational. No, that's not the case. Can't be a perfect square. So here, the square root of 49. Well, if you see the square root of 49, and let me do some erasing again because I got a lot of junk on here. So the square root of 49 shows up right here. 49 is a perfect square. It's highlighted in yellow. It is a perfect square. And right here I wrote, perfect squares are rational because it's 7. So this equals 7. Well, is 7 a whole number? It is. So this one is rational. This one is rational. So square root of 10. I have to look. Is the square root of 10 a perfect square? Is it highlighted in yellow? And the answer is nope, it's not. So that makes this one irrational. Irrational. Now, here's the square root of 4/9. Now remember, you can split this up and do the square root of 4 over the square root of 9. Square root of 4 is 2. Square root of 9 is 3. Now what do you got, ladies and gentlemen? You have a fraction. So this one is rational. Rational. Okay. Negative 0.6 repeating. That's a decimal. And does it repeat in a pattern? It does. It's 0.66666666. So it repeats in a pattern. So that makes it, repeats in a pattern. That makes it rational. All right, I'd pause the video, try the next 3 out, and then play the video again and see if you got them right. So 1.3 repeating. Again, a decimal. That repeats in a pattern. Rational. This one, a little bit tricky. Square root of 1 over the square root of 5. The square root of 1, that's a perfect square, and it's 1. The square root of 5, is that a perfect square? It's not. So I still have a square root, and it can't be written as a fraction, so therefore it is irrational. This one, fraction, so it is rational. This one, notice it repeats, and actually technically, I'm sorry, it should have ... after it. That's a big clue too. But it's 606600666, and so it repeats, but that's not in a pattern. A pattern would be something like 06060606, and it doesn't do that. So then that means it's just randomly repeating, and it is irrational. So rational, irrational, and placing things on number lines. Use this to kind of help. And we're not worried about this. Good luck.